बच्चे कैसे पैदा होते हैं? How are babies made? It is the oldest, most universal question of childhood. Typically, the answers are gentle fictions, like a stork dropping a bundled cloth from the sky. Beneath those stories lies a physical sequence of events, a self-assembling cascade where every human life begins as a single, instruction-heavy cell. Without an external architect, the human body organizes raw materials in total darkness. It manages to build a functioning brain, a beating heart, and articulated limbs entirely from scratch. To find the real answer to that childhood question, we have to look past the myths and track the 40-week biological timeline, starting at day 0. At the microscopic level, conception begins as a race. Millions of sperm navigate a high-stakes path toward a single waiting egg. Fertilization is a massive transfer of data. 23 chromosomes from each parent lock together, forming a unified code. This single cell now holds the complete genetic blueprint for an entirely new person, containing every instruction needed to build a body, from eye color to bone density. Immediately after fertilization, the cell begins acting on that data. It splits into 2, then 4, then 8, rapidly multiplying into a dense cluster. Conception marks the point where the biological instructions for a new person are successfully downloaded and compiled, initiating the sequence that will construct every organ and limb. Over several days, this multiplying cluster, now called a blastocyst, travels down the fallopian tube toward the uterus. To survive, it must clear a difficult hurdle: implantation. The cluster has to successfully embed itself into the uterine wall. The cells chemically link to the uterine wall, constructing the placenta, a temporary specialized organ built for this pregnancy. It acts as a two-way exchange system, continuously filtering oxygen and nutrients from the mother's bloodstream into the developing organism. Before the body can build the baby itself, it first engineers this temporary habitat to sustain it. Once the support system is active, the process moves into organogenesis. This is the window where identical stem cells differentiate to form the foundation for all major body parts. One critical step is the folding of the neural tube. A flat layer of tissue curls inward to form a pulsing cylinder, which will become the central command center, the brain and spinal cord. At the same time, a microscopic heart begins its first rhythmic beats, circulating blood through the early frame. The first trimester ends, the embryonic stage concludes. The process shifts, focusing on physical growth. In the final weeks, the fetus practices survival functions. It simulates breathing by moving amniotic fluid and tests its muscles through constant movement. These trimesters serve as a masterclass in automated engineering, turning a microscopic dataset into a functional, practicing organism. At the end of the 40-week countdown, the physical space inside the womb reaches its structural limit. This diagram illustrates the trigger for labor. A signaling loop begins between the fully formed baby and the mother's brain. The mother's brain releases the hormone oxytocin, which commands the uterine muscles to begin the rhythmic contractions necessary for delivery. Entering the world requires an immediate transition. The baby must switch from fluid-based life support to breathing atmospheric oxygen for the very first time. So, how are babies made? The answer lies in this 40-week timeline, a mechanical process of self-assembly that